look at the type of data that you'd see in a scatter plot. So a scatter plot compares bivariate data. That's two quantities, and you're comparing them. The data is always a set of ordered pairs, and you always want to have an equal number of x and y values so you can graph. So you'll graph along the x and the y-axis in a scatter plot. You do not connect the dots. You may see an outlier in your data. That's a data point that's far removed from the rest. I'll give you some examples of that. Okay, so let's say we're comparing in our class students' shoe size and height. We would probably see a positive correlation there. As shoe size increases, so would a person's height. If you think about it, people that are taller usually have larger feet, and people that are shorter usually have smaller feet. So therefore, that would be a positive correlation. An outlier would be if you found somebody that is very tall and has very small feet, or somebody that is short and has very long feet. That's an outlier. Sometimes you'll see a dot far removed from the rest. Okay, let me give you an example of no correlation. Just think of anything that you would compare to shoe size that probably would not have any relationship with it. For example, IQ. Let's say you ask people, what is your IQ and what is your shoe size? I very much doubt that shoe size has anything to do with IQ. It's not like you're smarter if you have larger feet. Okay. Next, we're going to look at a negative correlation. Time and distance from home. So one of the things you always want to keep in mind is that when you, so when you're looking at a scatter plot, time, any type of time like days, months, years, is always graphed on your x-axis, and then on the y-axis, what you're comparing it to. So we are going to start further from home, and as you walk towards your house, the time is going to increase, okay? So you're getting closer and closer to your home as time passes, so therefore you would see a negative correlation here, okay? Let me give you something that it would be a nonlinear relationship. Something nonlinear might be an example like dropping a ball from the top of a building. If you were to drop a rubber ball from the top of a building, you would get probably like a large bounce, and then as it gets closer and closer to, as time passes, it would get closer and closer to the ground. So you would see probably a non-linear relationship there because it would be kind of like curved because you're getting closer and closer to the ground as time passes, but there's no real tight correlation in the data because the bounce pattern is going to be like up and down, up and down, up and down. So that would be an example of a non-linear. Okay. Let's look at one that might be, well, you decide if it's positive or negative. I'm going to look at the cost of a pizza versus the number of toppings you get on that pizza. Okay, so if I was going to graph something like that, I would say number of toppings and cost. Okay, so if I get one topping, it might be $10 for the pizza. 2 toppings would be a little bit more expensive, wouldn't it? 3 toppings would cost even more. 4 toppings, depending on what they are, probably a little bit more. So as you can see, as your number of toppings increases, your costs will also increase. That would be a positive correlation. As you can see, the dots are going up in a pattern from left to right. That's a positive correlation. So